All right. So there was a question that got brought up yesterday. Figure we go over it as a class. As you guys are all going to be taking the Class C brake adjuster exam, right?
Yeah.
What is the maximum weight that you will be allowed to test? Do you guys know that?
Under 10,000?
Under 10,000 GVWR. Okay. So you guys want to remember that vehicle comes in. Let's say you get a F450 that weighs 4,100 or 14,410 pounds. Can you inspect it? Nope. So that would either be a Class B or Class A. All right. So you guys can't inspect it. It's out of your weight class. Okay. Good thing. The reason you want to remember that is our certificates are all handwritten. So you can write out a certificate for a car that's out of your class and still certified. DMV will still process it. But if BAR comes out and audits your certificate book, okay, that's going to be a problem because you just certified a car that you're not authorized to certify. Does that make sense? Okay.
Why is it 10,000? Is it because of the load of the lift, or?
No, just vehicle weight in general. Usually over the 10,000 pound mark, they're going to be heavy duty braking systems,
right.
so it's a little bit different than what we're used to.
Right.
Class A, you're going to have to take the state exam for air brakes, vacuum brakes, and hydraulic brakes.
That's A.
That's Class A, yes.
That's right.
You're still to test. With your Class A lamp license, you can inspect anything. Okay, there's only one license for lamp, but there's 3 of them for brake. If you guys do plan on taking the A later, get your C now, start working with that, train yourself on A, and then upgrade to A. It's a lot more money. It's a shitload more work, but it's a lot more money. Yeah, so it's a lot. Go ahead. Okay. We're not going to touch anything on vacuum or air brakes. And the reason why is I'm not certified in it, so I'm not confident in teaching it to you. So the only classes that I teach are classes that I have some sort of certification on and training. If I don't have any of those two, I'm not teaching it to you. Because then I'm just going to be up here bullshitting you. Right? Keep it real. Right? Does that make sense? Okay?
Well, even I know it's already passed, when you say Laredo run out, the max is 2,000. At that moment, if the rotor can be machined to take away those max,
as long as you have enough material left, yes, you can machine it.
But anything more than that would be already.
That's a rule of thumb. You always have to check it on the manufacturer, though. Yesterday, the Chrysler was .005, right? So that was different than what I told you guys.
So that answer won't apply to the answer straight up is the one that you said.
Manufacturer. Mm-hmm.
So that's almost like how when you're doing the timing for the smogs, that if the manufacturer says one thing, you don't have to do bars through degrees.
Right. So, perfect example. If you're looking up timing, right, and if they give you a timing range between 7 and 9, your plus or minus 3 doesn't apply, right? For my smart guys, you guys know this. So that's the same concept here. We have a rule of thumb, but that rule of thumb doesn't apply because the manufacturer gives you a spec. If for some reason they don't give you one, then you can use that rule. Does that make sense? Okay? All right. So today we're going to be talking about ABS, stability control. We're going to use an oscilloscope today. How many of you guys have ever used a scope? All right. So we're using a scope today. Okay. We're going to be using a couple different types of scan tools, and you guys are going to be doing some diagging today. Okay? Want to sit up here? All right, cool. All right, so let me give you guys the answers real quick. How many of you guys did the homework? All right, those of you guys who didn't, I'm going to give you the answers. Okay? By the way, like I've told you guys, and I'll tell you guys again, all this stuff is stuff I saw on the test. This is why I made worksheets or handouts with those. So the more you not do them, the more you're not likely going to pass the test. Does that make sense? Okay. So just like I told you guys on day 1, is I'm going to push you as much as I can, but you got to put some work in too. Okay. When you go take the test and you fail it, don't come back and tell me that it was my fault.
To be honest with you, I know on this case, I know what the answer on that is, but to put it right here is complicated for me to look at.
You got to. Let's do it.
But
muscle memory.
He said, cost of wearing down only on the inboard pad. You know, I know because it is right there.
Mhm.
But then to set it up here, I'm not.
The reason why I do that, okay, is most of you guys, whether you know this or not, you are a visual kinesthetic learner. You guys know what that is?
Yeah.
Okay? That means that you learn visually and by doing. So by seeing and by making you write it, you are learning it. Okay? So that is why I'm pushing you guys to see it and write it. Okay? I've trained enough technicians where I know 99.9% of us, including myself, we're visual kinesthetics. Why do you think YouTube is making so much billions of fucking dollars? Right? We watch a YouTube video and they're like, oh shit, alright, hold on, pause, let me go try that. Right? Okay? And then you come back, play again. Okay? That's visual kinesthetic. That's why I want you guys to write it in.
That's the fixed one.
Yes. So let's go over them real quick. Across, number 2, would be stuck slide. Number 5 across is floating caliper. 6 across is riveted. 7 across would be point, you're not going to put the decimal, but 001. And then 9 across would be run out. 1 down would be sliding caliper. 3 would be fixed caliper. 4 would be bonded. 6 parallelism, and for some freaking reason it's not showing me number 8. But it's in your guys' book. Okay, you guys have the PowerPoints as well. You guys have the answers, right? So now that I gave you guys that cheat sheet, there should be no excuse why you're not doing this. Does that make sense? Okay, it's in your book. Okay.
So that one that says stuck slide, like I'm right here on where it's mentioning it says if the inboard pad on the floating or sliding caliper is worn more than the outboard, the caliper needs to be replaced or rebuilt, or the slide's replaced. But I don't see anything about the stuck slide.
Yeah, on that.
Like, is that something you just went over while you were talking?
Yeah, that was a verbal
Yeah,
thing.
that's why
Yeah.
I was getting a little bit.
Yeah.
Sliding pink, that was pretty much something that would come to my mind.
Okay.
Stuck slide.
Stuck slide.
That
Yeah.
was getting confused.
It's a pin, right? If it's stuck, is it going to be able to move? Once we relieve pressure, it's going to stay in the same spot.
That way, yeah, but either way, you know.
So here's what I want you guys to take from this. Just because I wrote it different than what you know it how, you would have failed the state test because of that. For those of you guys that already took the state test, how are the questions worded? They're going to give you one question, and all 4 answers fit. Okay? All of them. And I took the test, I know. You read a question,
Slide would,
so they'll give you a question, they're going to say stuck slide, a slide that's not moving, a bonded slide, or a damaged slide. Then you got to make a call, right? Just because you don't know it as stuck slide, you're going to be like, oh shit, it's not that, it must be something else. Okay? So that's why it's important that just because I wrote it different than what's in the book, okay, you kind of have to put the pieces together. Does that make sense?
Yeah.
Okay?
I saw that.
So I'm pushing you guys in a whole different way.
Number 9, number 7 got me, no. Number 9 and number 6 got me confused, right?
Okay?
When you go back in the book, parallelism will cause the break of the bolts.
It can.
That's what it says.
They both can. They both can. So the
Parallelism for number 9.
okay. So pedal pulsation is usually going to be more on a run out situation. So that's what you're going to see with your dial indicator. Your dial indicator moves back and forth, right? So if the pedal's warped or the rotor's warped, as you spin it, it's going to do this. So you're going to feel that in the pedal, right? If it's parallelism, out of parallelism, meaning you're going to have high spots and low spots, it's also going to cause the same thing, right? Because when your pads are going across the rotor, what are the pads doing? Opening and closing, right? So what do we feel in the pedal? Feel that, okay? So it can be both, they're just measured different ways. Does that make sense?
But even the spots and the crosswords don't match up.
They're off? Did I mix them up?
This is supposed to be number 6, and then this is supposed to be number 9.
They go the opposite, sorry.
Yeah.
That's what happens when you write shit like at 2, 3 in the morning.
Oh, we're gonna fail it.
My bad. For one question, I got you guys. Alright.
You're checking to see who pays attention.
Right, I'm just making sure you guys are awake. Because I don't know how the hell I'm awake, but you guys are awake. Alright, so going back to this one here on the next one, across we're going to be bonded shoe for number 2. Number 3 is going to be primary. Number 6, dual servo. 8, self-energizing. And then anybody got the answer for number 9?
Secondary shoe.
Secondary shoe, okay. Oh, it's up there. And then number 10, backing plate. 11 would be brake drum, 12 riveted, and 13 return spring.
What's 11? 11 drum brake.
Drum brake. Or brake drum. And then the other part, down. Did we miss any? Or did I put this shit in place? No? Yeah. Self-adjuster, parking brake, hold down, and wheel cylinder. Okay. So right now that we were talking about test-taking strategies, here's one that I learned not too long ago, and I want to share it with you guys. When you guys are taking the test, okay, the one thing you guys want to focus on is which one of these faults is common. Okay? And the reason I say that is because as technicians, when you go take a test, they're going to give you 4 possible faults, right? Usually what happens is we start over-calculating the diagnosis or what's happening, and then we come up with an answer that's not even listed. Has that ever happened to anybody?
Yeah.
Okay? And then you start talking to yourself like, damn, they're wrong or I'm wrong. One of us is wrong. It must be them. Right? So then, what's your next best thing? I got 4 answers. Fuck it. Eeny, meeny, miny, mo. Right?
Well, ASC is like that. Sometimes you read a lot, and a lot of questions, the way how they ask it, the answer is, not close.
I have tricks to that, but you got to take my class in order for me to show you those tricks.
What about the money now?
So when you're taking the test, okay, this is what you need to remember. The first thing you do, and you guys probably already heard this, but I'm going to tell you this because this year alone, I've taken 8 ASCs, okay? I've renewed most of them. I took my braking lamp again, so I'm constantly taking tests. Does that make sense? Okay? So I'm going to give you guys some pointers on it, okay? Here's how it goes. First thing, you read the question, okay? Basic. But while you're reading the question, you're looking for key points. Still with me? Okay? What are some key points? Well, let's look at a question. Let's say, for example, I help compensate for brake shoe wear. Okay? Brake shoe wear. That means that the pads are getting low. So what are some of my key points here? It's going to be compensating. If I'm getting some wear, something needs to compensate. Something needs to give. Right? Shoes are getting smaller, so that means they're going to have to travel further out. Right? If I'm not adjusting them, who's going to adjust them? Gremlins? Right? Who's going to adjust them? Self-adjuster. Okay? What if they gave you an answer like a technician, or technician B is going to adjust them, or your parts guy is going to adjust them, or they self-adjust, or the computer adjusts? What would be an answer? They self-adjust. Okay? So when you come and take a test, you're always going to look for key words within that question, number 1. And then number 2, okay?
That say help, compensate, and between technician A and B, but it's saying help, not being service, that would be the self-adjuster.
Right, because they're not talking about being serviced.
Yeah.
So those are key words. Now, if they're saying the vehicle's being serviced, that means it's on a rack, all the tires are off, and you're in there.
Yeah.
See the difference?
Yeah.
Okay? If you guys took the smog test, right, if they give you a question that said, before you start the inspection, right, Travis, you should know this, right? Are they referring to, can you abort it or reject the vehicle for inspection?
Reject.
How many of you guys agree with reject? Okay? If you said abort, you're wrong. Because an abort, you can only abort once I started the test. And they're telling you that the vehicle just showed up and you're winding it up, so you haven't started the test. Even if the car's already in the shop, you haven't started the test. When do you start the test? The moment you scan your badge, you put your access code, and you scan a DMV document. Like we say in aviation, you're committed. Okay? So that means that you scanned it, you're smuggling that fucking car. Does that make sense? Okay? So going back to our questions here. Once you read it, you find some key points. The next thing is, you got 4 possible answers. Not 5, not 6, not even the ones in your head. Those aren't possible. Which ones are possible? The 4 in front of you. Okay? So then now what you need to do is you need to look at what are these 4, or which one of these 4 is one of the most common situations that I've ran across. Okay? Why? Because you can look at it and say, well, I had one car in my 15 years as a tech that had that problem. So it could be that answer. B, I've never seen that. C, I've done like 14 cars like that. And D, every fucking car that comes in has that problem. So then what's your answer? D. Okay? More than likely, then what you're going to do is you're going to look them over. Does this make sense? Does this fit? No, get rid of it. Does this fit? No, get rid of it. Does this fit? No, get rid of it. Does this fit? Yes, go with it. Does that make sense? Okay. How do I know this? Because I've taken tests on subjects that I've never even studied, and I passed them. Okay. So I came up with the test-taking strategy. It works. Okay. I'm a true believer in it because I use it. Does that make sense? Okay. So that's what you need to do in order to take the test. As we go along, I'm going to hit you guys with more of that stuff so this way we can get you guys on your toes. Alright? This break-in lab test, no bullshit, is written by a 2-year-old. And I think my 3-year-old did write way better than the way this test was written. Okay? If you guys read, once you guys get there and read the questions, you're going to hear me talking shit in the back of your head. When you're taking your test, in the upper right-hand corner, there's a little comment section. I'm pretty sure they fucking hate me now from all the bad comments that I put in those comments. Okay? They are written bad. I mean bad. Okay? And it seems like they're doing it purposely so this way nobody passes the test. I know instructors who can't pass this test. Okay? I know a couple students that have had their license as long as I have, or longer, and they can't pass this test. Okay? So, let's go with it together, and then I want to give you some tips as we go along. Alright? So let's get cracking. So, we're going to talk today about EBC, or Electronic Brake Control System. When we take you guys outside, we're going to be using a scan tool. We're going to be using a scope. Alright, so I need everybody to be on their toes today, because there's a lot of stuff on that on the state exam. Okay? Question?
Yeah. What is the difference between dual servo brake system and self-running adjustment?
The dual servo is going to have... Damn, I don't even have it up. From the dual servo is going to do the same normal movement, plus it has the adjuster at the bottom.
Oh, that's it. Okay.
Mm-hmm. I had to visualize it.
Well, the dual servo is the one that has the adjusters on.
That has the adjuster on the bottom. The single one does the same movement, but they're usually held at the bottom by pins. So the brake shoes are going to be steady, and all they do is flex. Where on this one, they're gonna move, flex, and they're also going to self-adjust. The self-energizing dual servo has an self-adjustment screw. All right. Okay, cool. So let's go ahead and talk about electronic brake control. What the hell is that? Isn't that just another way of saying ABS or a computer-controlled braking system, right? So here's the kicker. When a lot of technicians see electronic brake control, they get, right? Because it's electronic. Oh, fuck, it's electrical. That's not my thing, okay? Why? All right? I know a lot of people that freak out once they see electrical or electronic in any automotive statement, okay? They see diagnostic electrical faults, like, no, give that to that guy, I'm not touching it, right? Okay? So we're talking about electronic brake control. These systems integrate computer controlled into hydraulics. Okay, so like we were talking about, electro-hydraulic braking or computer controlled braking gets done through these types of systems. Are they any different than our normal general hydraulic braking systems? No. What's the only difference?
We have apply the pressure.
We got an input, and then we also have outputs. Okay? How many of you guys know how to diagnose a car that has an engine computer? Okay? How do you diagnose it? It has inputs, and it has outputs. No shit, right? ABS computer. Is it any different than an engine computer? Is it any different than a transmission computer? What does a transmission computer do? It looks at input sensors, input shaft, output shaft, right? TPS, engine load, vehicle speed, makes a calculation and then sends information to shift solenoids. Is that true?
Yeah.
Okay. So is this any different? What sensors is the vehicle looking at to make any type of calculated assumption on how to apply the brakes on a computer-controlled car. Vehicle speed sensors, right? If it has one, okay? Or we have ABS wheel speed sensors, right? Most cars now have 4. Most, okay? What else would the computer look at to make a calculation for braking?
Most new cars, they have the electric steering.
Steering angle sensor. You guys ever heard of those? Okay, the yaw rate sensor, okay? I also heard stoplight switch earlier, or brake switch, okay? What else?
Brake pressure switch.
Brake pressure, well, if it has one. Most of them still have just a switch. Yeah. That's more high tech. That's like a potentiometer because it has position, so it knows how much you're actually applying on braking and stuff. That's a little higher end.
Pressure into the Ford master cylinder.
Oh, you're talking about just master cylinder pressure. Okay. What other inputs besides that?
Well, the level, you know.
Fluid level. Is that a good one?
Yeah.
All right, you guys missed the most important one. All right. So all of those are sensor inputs. Is that true?
Yeah.
So if you get a car that comes in for a braking lamp inspection and the ABS light's on, you got a yellow ABS light on, what is that telling you right off the bat? Something's wrong with the ABS, but what else?
It's not being working.
It's not working.
Yeah.
So if you pull a car into the shop and it has a yellow ABS light on, what's the first thing that should come to your mind?
It's not working.
This guy must be Flintstoning his ass because his ABS system is not working. Is the car going to stop? Absolutely. But in an emergency, is it going to stop? Once it hits something, okay? Because that car's going to skid, okay? It's going to lock up. Why? Because the only one doing the work at that point would be the master cylinder. True? Okay? So if you get a car that comes in and has the ABS light and it's on in yellow, right? We know for a fact now that this vehicle is not going to be able to stop in an emergency situation, right? What are you supposed to do as a technician if the vehicle is already getting a brake and lamp inspection? Tell it? Pass it? Call the dealer? Diagnose it? Do what?
Send it to rest.
Send it to the rest?
Well, you have to first, plug it in with the scanner and see what kind of holes are, and then go from there, no? On that matter, because it's electronic. It could
Okay.
be mechanical related too, but
Okay.
it's gotta be a code.
Well, he's not there for diagnostic, right? He's there
Yeah.
to master.
But how you can, you have an amber light on, how I will know the ABS, I need to know the ABS module like on Chevy,
Mhm.
how the pump electric motor goes bad.
But
Okay.
The module, so.
Okay.
it's not like the small check that you're just there just for checking or for diagnosis.
Okay. So when it comes in for a braking lamp, what did they authorize you to do? Inspect, right?
Not
Once you're done with the inspection, the ABS light's on, can you now tell them your vehicle failed because you have an ABS light illuminated, okay? Would you like me to diagnose it? This is what it costs to diagnose, and do you authorize me to diagnose it in order for me to certify your vehicle? Right?
no.
Okay? Why do we need to go that route?
Experience,
Because to get paid, one, but two, follow procedures, right? Bar wants you guys to do whatever is written on the estimate. If they authorize an inspection, what are you going to do? Inspect it. Okay? Now, if the light is on, that would usually mean or constitute an automatic failure.
Without
Okay.
getting deeper into it.
Without getting into it. You are going to get a question on that says the vehicle comes in, the light's on, what do you do? Right? How do you proceed? Okay? Run the inspection. Okay?
Is that like when you do a small check-in, like off time, you still do the inspection?
Hell yeah. Yeah. Absolutely. Right? I know a lot of shops, they see a light and they get scared. Turn right back around, tell them, here, your light's on, go fix it. Why? Why? That's smart takes, you guys need fells. Right? If you're not felling cars, you look bad. So fel it. And then tell them, hey, your light was on. Right? They're going to talk shit about you anyways. So it's not like people wake up and be like, I can't get smog today. Right? They don't like us, so might as well just do your job.
So the question that you said is the light in the vehicle comes on with the ABS light on. What would you do?
Full inspection. And then fel it.
And then further light.
Yeah. But you're not going to pull codes.
Yeah.
What if they go, hey, my ABS light is on, are they gonna fail?
Oh, in that case, you can tell them, yeah, more than likely it is.
I think so.
Yeah.
More than likely.
More than likely, this sounds a lot better. If you say I think so, then they're gonna be like, oh, okay, cool, I might be able to get through. And then once you fail, they're gonna be like, I thought you said it might pass, right? So you just better off just let them.
More than likely.
Yeah, if they ask you, be like, more than likely it's gonna fail. Okay? Because most vehicles do a self-check, right? First 5 seconds of key open, it does a self-check. So if the light doesn't turn off, what does that mean? There's a problem. Check engine light, my smog text. When you go do the mill functional, does the light need to turn off?
Yeah.
Why?
You know, this is working.
That's a self-test, right? If the light stays illuminated, there's a problem. You think the ABS pumps will do anything different? Same thing. Okay? And most of the time, if you don't have a good scan tool, you can't reset it. Okay? And if you have some vehicles like Nissan, you might have to use a paper clip to jump the ABS connector so you can get codes out of it. They still go old school. Okay? So certain things you guys need to know. Does that make sense?
Does the ABS have monitors, like, check engine light?
No. No. It's just going to give you codes based off of some of the inputs or an actuator.
Will pending codes turn the ABS light off, or does it depend?
They won't pen, because that's a safety.
For the ABS.
You might. Toyota does that as well.
I was gonna say, sometimes,
Yeah.
a different module will request the, check engine light to come on. I've seen a lot of Chrysler where their transmission control modules will
Mhm.
throw a code for a check engine light, make them an open check engine light on, you go and check it with the P700, it says the other module.
That's what I was saying, Chrysler.
Yeah.
It's the one that I see that is most like.
Yeah, you'll see that often. Depends on the manufacturer. Some manufacturers store codes on all modules, some don't. Some store monitors on all modules. If you guys know European, they usually store half the readiness monitors on one ECM and the other half on another one. Okay, so it just depends on the manufacturer. Okay, it's kind of like when you're talking about CAN bus, where every computer is going to have a U1000 except for the computer that's bad. You guys ever run into that type of situation? Okay, that's the same concept here. Okay, so when we're talking about ABS, we're using that for being able to control or steer ability. You guys ever heard of that term before? Usually what happens when you lock your brakes, what's going to happen to your ability to steer or control the vehicle? You lost that, right? Okay, back in the day when these tanks were rolling down the freeway, right, and people were slamming on the brakes, what were the back wheels doing? Locking. Once they locked up, what happened to the car? Started fishtailing, and then they started to overcompensate, and then the car would roll or just end up smacking into another car, right? So then that's why we went to electronic brake control.
Why do wheels lock up, though? Can't you just let go of the brakes?
You can, but the thing is you got seconds, right? So imagine you're in a full slam brake situation without ABS, right? Car in front of you is completely stopped. By the time you checked here or here, you probably already hit the car in front of you. So that's not even giving you enough time to be like, oh shit, let me pump the brakes real quick, right? Like, nah, it won't happen, right? So that's one of the reasons why. And then, since back in the day, it was just full stream of pressure, locked up, and that was it. So then that's why we started pulsating it, and that's what's giving us better results with braking. So manufacturers wanted better than just ABS, so we added electronic stability control, okay? Those of you guys that do Euros, you guys have been seeing this for years, right? Okay? So this adds more information to steering. Yaw rate sensors. How many of you guys do alignments? Okay, newer cars that come in, what are you supposed to do to the yaw rate? You got to calibrate it. You got to relearn it, right? If not, what's going to happen? You're going to have some problems, okay? Very unhappy customer. If you got a vehicle that has electronic steering, power steering, do you really have to calibrate that? Oh yeah, okay, you want the car to steer, okay? So electronic stability control adds a few sensors, so now we know, are they moving the wheel, how much are they moving the wheel, and which way are they moving the wheel, okay? All that information goes into the BCM, or the body control module. Body control module makes some calculations and then sends out commands to, up into and including ABS, TCM, and PCM. Some ABS modules will actually reduce power. Okay, so if you got a vehicle that will do that, it'll reduce power on the engine to help the vehicle stop or come to a stop or slow down. Okay, so all that stuff can be put together, just makes our equation as a technician a little bit more difficult. Right? Is this an engine problem, transmission problem, or a braking problem? Okay. How many of you guys have ever lost control with an either understeer or oversteer type situation? Okay, what kind of car?
My 92 Ranger.
Oh. All right. What kind of car? I saw somebody over here. Anybody? No? All right. Motorcycle? Okay. So when we have an understeer condition, what is this indicating to us? That means that you're too deep into the turn. So what's going to happen to the back end? You're going to skid off, right? Okay. This is kind of the stuff that you see. How many of you guys watch NASCAR? Right? It's rather boring because they're just going in circles, right? But obviously, if they understeer, what's going to happen to the car? Spin out, right? If we oversteer, what does that mean? That means that we're going too wide, right? And the vehicle is going to kind of just veer off, and you're going to end up crashing into something. So all this information is used by the computer in order for the computer to make adjustments, right? I know on day one we were talking about the old rollover on the Explorers, okay? This is some of the stuff that got added to prevent those types of rollovers, right? Some computers are also using an HCU. What is that? Hydraulic control unit, okay? Yesterday I made a comment that when you open up the switch, if you hear that pump come on, is that a problem?
Yeah.
More than likely you have what kind of problem? You have a hydraulic pressure loss. Why? Because it's supposed to maintain pressure. Is that true? Okay, so if that system's dropping pressure, you got a leak somewhere, either internal or external. So look for external leaks. If you can't find any, you're going to start testing for internal leaks. Okay? So the body control module receives input signals from the ABS sensors, compares these to data stored in the memory, and decides the necessary action and sends an output command to the hydraulic control module. Okay? So just like a regular engine, that the computer looks at sensor inputs, makes an educated calculation, and then makes output commands, this does the same exact thing. Okay? How many of you guys have ever had a car that had a bad ABS wheel speed sensor and you would get ABS light coming on or flashing while the vehicle is being driven? Chrysler? Anybody else?
Prius.
Oh, the Prius?
Well, there are some cars that won't get idle, won't shift.
No. Yeah.
The signal goes to that.
It goes right into it. Okay? So it's kind of like a gateway or a host. All right? So you guys got to keep that in mind. The reason being is if you need to diagnose this, you're not going to lose your cool, right? What are you looking at first? Let's forget brakes. Let's talk about engines. If you're diagnosing a car that has a check engine light on, what's the first thing you're going to do? Pull codes, right? Okay, what's the second thing? And if any of you guys say clear codes, I'm going to smack you, okay? Because you do not clear codes until you fix the car, right? You're going to check freeze frame. Why do we want to see freeze frame? We find out the condition in which the vehicle was operated at the moment the code came into effect. Is that true? Why is that important to you? You didn't know how the car was being driven. Okay, what if they bring you a car with a check engine light on, you don't check freeze frame, and you spend 4 days on it and you can't figure it out, then when you finally check freeze frame, you find out the problem happened at cold start.
But the vehicle is misfiring 80 miles an hour, and you are driving this.
That's a different story. 80 miles an hour, and it's misfiring. You're driving on passenger, right? If you want me to go.
There are cases like that.
Yeah. Oh yeah.
All the problem happens on the freeway now. Well, how many miles? It's 80.
Yeah. It's like,
Oh yeah, right.
yeah. 80 in California means about 100-ish.
Yeah.
There's no way I'm driving a car at 100 miles an hour trying to figure out what's wrong with it. Okay? So, now that we know that the freeze frame is going to give us the data we need to determine at what point this happened, then what do you do after that?
Diagnose.
So after that, we're going to use any sensor input in relation to the system that's bad to determine what's going on. Is that true? Okay? Then from there, we're going to make a decision on where we're going next with our diagnosis. Does that same theory apply to this?
Yep.
If you pull a code and it's telling you it's a certain wheel, okay, where are you going to go check? That wheel. Okay? I say it sarcastically because I know a lot of technicians who get a code for a left front wheel and they check everything but the left. Okay? Problem's not there. It's got to be over here. Why? Because I know so. All right, cool. Fuck it. Okay, waste your time. All right? The guy on YouTube said it was that one. All right, fuck it. Or the guy in the forum said it was that one. All right, wheel speed sensors. How many of you guys ever replaced an axle, didn't check if it had the reluctor wheel, you put the car back together, it leaves, and it comes back with the ABS light on?
Wheel bearing.
All right? Or wheel bearings.
The pickup on the bearing.
We had a student in one of our diagnostic classes, he replaced the wheel bearing on a Chevy Malibu. Brand fucking new out of the box from GM. Okay? Because that day before, I drilled it into him, the aftermarket parts sucked. Right? So he went straight to the dealer. Then, for that class, he brought the car in because he said, I did what you said, I put it from the OEM, and it still gave me the same fucking code. Okay? So, cool, bring it in. First thing we did, we threw it on a lap scope. Why? That's the only way I can verify integrity of that particular cylinder. Wrong class. Okay? So, that sensor. How many of you guys scope them? Or most of you guys do scan tool and go drive it, right? Why is that not a good test?
Delay.
Not like that. Intermediate.
It's not live data. You know how long it takes that data from the time I ask for it with the scanner, from the time it gets sent back to the scanner, converted, and displayed? It's roughly between 10 to 15 seconds. So the data you're seeing on your screen is 10 to 15 seconds old. If there was a dropout in one of these sensors, would you be able to see it? You guys know how many people argue with me and tell me that's not true? And how many people argue with me and tell me that using a scope is a waste of time?
No, it's probably the best.
You guys know how we figured out that Malibu? With a scope. Okay? They drove it here with a scan tool, and they had the data because they were recording it. They're like, there's nothing wrong with it. It's working. Really? Huh? Put on the scope. Let's see what the scope has to say. The moment we spun the wheel, we started noticing that every third tooth was elongated. So the computer seeing an elongated tooth as, damn, this revolution doesn't stop. It just keeps going. Then, oh shit, another tooth. So we pulled everything apart, and there was nothing wrong with the reluctor wheel. Okay? Sensor tested out fine because they tested resistance on it. There was nothing wrong with the sensor. What ended up happening was that bearing was bad. Didn't have noise, didn't have vibration, nothing. Okay, it was a bad part right out of the box. Okay? I bring that up because most technicians will be like, well, I put a new part in it, it's not that. Order me a sensor. They throw a sensor on it, fuck, that's not it either. Wiring harness, they throw a wiring harness at it. Shit, that didn't fix it either. It's gotta be the fucking computer. Order me a computer and call the programmer to put it on. Right? $5,000 in the hole to come to find out you had a bad hub. Okay? Now you guys see the importance of a scope, right? Hopefully.
Yeah.
Okay? I love scopes. I've been using them ever since I started automotive, and all the old farts I used to work with would make fun of me. I worked in most fully Hispanic shops, so they always tell me, "Tráeme tu cajita, see what's wrong with it," right? Bring your little toy, let's find out what's wrong with this car. They're mocking me, right? Now, guess who fixed all their fuck-ups?
You.
Okay? So you gotta learn how to use a scope. A lot of people are gonna tell you, scopes is old technology, you don't need to use it. Okay, cool. So go ahead and tell me how swapping parts is working for you, right? Okay? Now, let's talk about ABS braking. What's the number one thing you guys need to remember when it comes to ABS? When is it going to work? Under extreme braking conditions. That's a huge chunk of your state test. You're going to get questions that ask you about when does ABS activate. When? Extreme or emergency braking. Okay? So if the question you have is talking about anything in relation to an emergency stop or brake situation, what are you using? ABS. Okay? So during normal braking, no ABS intervention is needed. We don't use it. So when the car is being stopped normally, we're going to still use the master cylinder. Okay? Your isolation valves inside the ABS pump are fully open, so it's just going to go right through it and right back out. Okay? So the only time we're going to be using it is under extreme circumstances. The body control module consistently monitors the speed of each wheel. Why do we need to monitor each individual wheel and the speed of it?
To make adjustments, calculations.
To make adjustments. You guys ever been driving down the road, it's raining, and all of a sudden you see your traction control light flicker, and then your car feels a little weird? Why do you think that happened?
You lost traction.
Your body control module noticed that one of your wheels spun too fast or too slow compared to the other ones. So what did it do? It took over. Okay? You didn't even realize it until like, oh shit, my ABS light flashed or my traction light flashed. What the fuck? Oh, it went away. Oh, okay, fuck it. Keep driving, right? Okay? Or if it stayed on, oh, let me move my check engine picture over here. Oh shit, now I need another picture. Right? Okay? So the module noticed it. You didn't. Computer did. So what did the computer do? It made an adjustment. Why? Because by the time you realized it, it was already fixed. Okay? If one wheel speed sensor signal is more severe, wheel deceleration, the body control module sends a current to the appropriate solenoid valve. Remember yesterday I talked about current testing versus voltage testing? What did they just say right there? Current. Okay? So if anybody ever taught you that you test for voltage, you got to change your thought process. Because voltage is always there. You're always going to have that pressure, but do you have flow of current? That's what you need to know. Does that make sense? Okay? So here the computer is going to activate current flow to that one valve. If I add current flow to any type of solenoid, what am I doing to it?
Activated.
I'm energizing it. Depending on the type of solenoid, it might be an open or a closed. Right? If that solenoid is usually open, when I activate it, what is it going to do? Okay? And what if it's usually closed? When I activate it, what does it do? Open. Okay? How do you figure that out? You look it up, right? You're paying for a monthly service subscription. Use it. Look it up. Okay? They're going to tell you. Usually when you don't know how to look this stuff up, how does this operate? This is what I do. I'll look for a code that's in relation to the component that I'm trying to figure out how does it work. Okay? The example I always give, because it works very well, is a P0101. How many of you guys know what that is? Of course you do. It's a Ford problem. Right?
I've seen them most of
A P0101 is a mass airflow code, right? Okay? I love that code. What is that code telling you? Math is probably underestimating, right? Because that'd be a huge problem. Okay? So by knowing that, then with a 101, now I can go into Mitchell and look up P0101. If I look up that code, it's going to say code description. So it's going to tell me why it said it, right? Right below that, it's going to say operation. In that paragraph, it's telling me how that system works and how that sensor works, and how the computer uses that sensor to make adjustments. Is that important to me? Yeah. So if you get an ABS fault, or you think you might have an ABS fault, wouldn't it be a good idea to look up ABS codes? Right? And then you're going to find out the operation of the system. Or you can go in the search bar and type in ABS pump or hydraulic pressure unit. Okay? Look it up and then see how it works. Why do I keep telling you see how it works? If you know how it works, can you diagnose it?
Yeah.
If you don't, can you? Okay? Sooner or later, you'll run out of money or parts, one of the two, if you don't know how it works. Okay? All right? I call it the old parts cannon. If you guys got one of those, put it away. You don't need it. Okay? So going back to that, if you're not sure, look it up. That's what you're paying for. Does that make sense? Okay? So when we're looking at the ABS pump, what is that? That's the HTU. Okay? So here, we have a dump solenoid and an isolation solenoid. We also have an accumulator. What would we use the accumulator for in this system? Maintain pressure. Okay? So we're going to route pressure into the accumulator there and hold it. As brake fluid gets hot, it usually creates nitrogen. That nitrogen pressure is going to be applied on the bottom side of that accumulator. So once we need that extra pressure, what is the accumulator going to do? Release it and push it out. Okay? So it's holding about, if I remember correctly, about 1,000 psi. So that accumulator is going to hold about 1,000 psi of pressure in that accumulator. If for some reason the ABS module says, "Oh shit, man, I'm trying to stop that wheel, it ain't stopping," what does it do? It shoots that at 1,000 psi right to that wheel to try to get it to stop. Okay? It holds it there. So it's holding it as a backup. basically. You guys remember the hydro boost unit? What did the accumulator do? It provided pressure for what? If we had loss of pressure, you were still going to have assisted braking, right? Is that the same concept?
Yep.
Okay. When it comes to ABS, we have two different types of ABS master cylinders. We have an integral type and non-integral. What's the difference?
One is integrated with the ABS system.
One is all one unit and one is not, right? You guys remember those? Okay. That's old stuff right there. Okay, so if that one on the right went out, you're not just replacing the master cylinder. What are you replacing?
The whole
The whole thing. Okay?
not available.
And no longer available. If your car has one of those, you're better off just retiring and giving back to the state. They'll give you $1,000 and then go get yourself a new car. Okay? You got the one on the left, you can just replace the master cylinder, right? So a non-integral ABS system uses a fairly standard tandem master cylinder with a typical vacuum or hydraulic power booster, just like we see today. Okay? Why? Because if we're not using the ABS pump, what are we using to stop? Master cylinder. Okay? So the master cylinder is going to do all the work. The only time we use ABS is under emergency braking. Okay? I don't know about you guys, but I hardly emergency brake. Okay? If you're always emergency braking, you might want to look for a driving school. Okay?
Good insurance.
Yeah, good insurance. It's usually the PT Cruisers. Nobody drives a PT Cruiser, right? I say that as a joke, but it usually always fucking happens. I get stuck behind a PT Cruiser and fucking cruising and slamming on the brakes for no fucking reason.
It starts overheating.
It starts overheating, blows the computer. Alright. So the booster assists the driver in applying the force to the master cylinder. The master cylinder sends fluid under pressure to the hydraulic control unit. Okay? If the pressure has to be modified, the computer-controlled solenoid valves in the HCU carry out the command. Did we already know that? Okay? So we need an input for the computer to make an output command. Right? In my diagnostic class, when I talk about computers, this is how I talk about them, because this is how it works. When we're talking about computers, I worked with a lot of old farts that worked before computers. When computers came out, what was the problem of any fucking problem on any fucking car? Computer. Why? Because it wasn't there before. Now that it's here, we got a problem. So it must be what? The computer. Okay? I used to love when cars would show up and I have 3 fucking computers sitting on the floor. I'm like, really? 3? You needed 3 of them? Oh, I wasn't sure if the other 2 were working, so I put a 3rd one in there. They're still not working. Okay? You must need a program. Like, bro, you went to 3, and it's still doing the same thing, right? And then usually come to find out it's a bad sensor. Okay? Loose ground, that's a good one. Okay?
Those Cadillac, you know what I mean? The earliest, that used to go back all the time. That was when I first started.
Throttle body injection Cadillac?
You know, a Cadillac with that computer under the glove box?
Mm-hmm. Oh, well, that's different, though. Yeah. But you're talking about replacing proms and all that. Yeah, that's completely different.
That
Yeah.
was just started. That was the
Those were awesome, though. How many of you guys were around with OBD1 on? Because you guys know Cadillac started live data since 1978, right? So, they were fun. I used to love them. So many people hated them. If you, like I tell you guys, if you know what it is, if you know how it works, you're gonna diagnose it. With OBD1, it only looks for open, shorts, and grounds. That's it.
That's what it was.
So if you get a code for an O2 sensor, go check it. Is it plugged in? Yes. Replace the sensor. You fixed it. Haha. Move on. Okay? How do you know you fixed it? Because it doesn't check for performance like it does now. We didn't have 171, 174 codes back in the day. We only had I think it was like a 21 for an O2 sensor on a Chevy. That's it. Okay? The funny ones on Chevys were when you had a check engine light on, you put your expensive-ass code reader, which is known as a paper clip, and pin A and B, and then your check engine light will start flashing. Okay? And you guys ever run into an old Chevy that gives you code 13, which means no codes, but the fucking light's on? Right? It's like, all right, hell yeah. Okay? That's when you replace the computer. Okay? Back in the day. Now it's a lot different. Okay? Now the only times I see computers fry is when the wrong person checked it or a solenoid went out. Usually it's the first one. Okay? I see a lot of techs with power probes. Those do not go anywhere fucking near a computer.
No.
Nowhere. Okay? Also, any of you guys have a power probe?
When people that's cheating,
Okay.
when they modify the system.
Oh, that too.
The computer, then you cannot get it back.
That too. I wanted to mention with power probes. We were testing one the other day. Power probes have a bias voltage. Are you guys aware of this? Okay, the reason I'm telling you this is because if you're using your power probe as a voltage testing tool instead of a voltmeter, okay, you're going to get wrong readings. And it's going to lead you in the wrong direction because of that bias voltage. If you guys read the owner's manual, your power probe is only supposed to be used to supplement voltage or ground, not as a voltmeter. Okay? I'm telling you this because none of us read owner's manual.
But there is a hook, the one they call it, the big one.
It checks for current. That's it. Use a voltmeter because of the bias voltage. We checked it. We figured it out. Not a good thing. Okay?
Yeah, so expensive. They say that this, that.
You got to be careful.
Activate the injectors and.
Even then, if you activate an injector, you can feed back and kill it. Because remember, when you turn off an injector, it's going to spike over 35 to 65 volts. Some injectors go up to 100. So you can feed back and kill something else. So that's why it's not a good idea to sit there and ground. Oh, I can hear it. Like, oh shit, it's not doing anything anymore. Why'd the engine die? Oh, fuck. Okay, then that's when oh shit, now I get, Mr. Customer, your computer's bad. It wasn't, but it is now. Okay, so that's usually how it ends up.
But I drove it in.
But I drove it there, right? Oh man, I was checking it, just died. Okay, don't end up in that situation. Okay, so with the master cylinder, if we still have a non-integral master cylinder, it's going to be your basic master cylinder. It's going to have a bore, primary, secondary piston, stop pin. It's going to have our normal accumulator ports. Compensating ports. We're going to have everything that's inside a normal master cylinder. The only difference is we're going to have a high pressure unit. Okay? That's it. All right? So don't assume when you pop the hood, like, this is ABS, I have no idea. Send it somewhere else. It's the same thing. Okay? I want you guys to get in the habit of just because it has a computer doesn't mean anything. Computer actually makes things easier for us to diagnose. Right? As long as you guys know what you're looking at. So the ABS control valves. Inside of the unit, we have several different types of valves. What are the two valves that we have in them? I called them out a little while ago. Dump? No? Starts with an I. Isolation valve. Okay? Those two are solenoids. Agreed? Yeah. What two things does a solenoid need to work? Power and ground. Okay? Being that it's a solenoid, we do not control power. What do we control to a solenoid? Ground. Okay, so if I'm trying to test one of these solenoids, first thing I'm going to do is verify that I have 12 volts to it, or 12.6, or whatever voltage, source voltage to it. Okay, agreed? Yeah. What's the next thing I'm going to do?
Ground.
Check the ground. How am I going to check the ground?
Are they changing that technology? Because remember, Americans and import car were different. America was controlling the ground side.
Every manufacturer is different. The majority of them use ground.
There was a time.
Yeah.
The Japanese were doing one thing.
They still do. Everybody does something different. GM, mostly GM does power control versus ground control, but everybody else does ground control. But that's why we teach ground control, because usually that's what everybody uses. Except if we're talking about GDI, on GDI injectors, we control the power. Because on a GDI injector, you're going to need about 60 amps to open that injector because it's inside of the combustion chamber. Okay, so any of you guys ever scope a GDI injector?
No.
Look fucking crazy. They look crazy. All right, so going back to this, because we ground control it on most of them, what's one of the best methods to determine if we have ground operation? Voltage drop. Test light. We could use a test light as long as the test light is the same resistance as that valve. Okay, that's load substitution, right? How many of you guys know the resistance of your test light? No. My test light draws 290 milliamps. Why do I know that? Because if I'm going to replace it with something that it's drawing, I need to know how much it's going to draw. Right? Does that make sense? Okay. So a test light wouldn't be a good idea. Would it be something else you guys might be able to use to see if there's pulsation there?
A scope.
Scope would be the best tool. Okay. How many of you guys have a voltmeter? I'm going to ask it again and again and again and again. Okay. How many of you guys know every function on your voltmeter? You got homework. Okay. There's a thing in your case that's called an owner's manual. I want you to open it and read it. Okay. There's a function on your meter called min and max. How many of you guys use that? Okay, or if it's a snap-on, it's going to be rev, right, or something like that, REV or RE something like that. Okay, what does that mean? Well, it's going to read the minimum amount of voltage and the highest amount of voltage. How's that going to help me?
I don't know what's going on.
When I ground the circuit, okay, depending on the type of transistor inside of the computer, I can have either a 300 millivolt above ground or 700 millivolt above ground. It all depends what transistor I have. So if I use my DVOM on the min and max function, and I power on my pump, right, and I see on my meter that it shows 0.300 millivolts, did it pull to ground? Yeah. I don't know how long, but it pulled it, right? Then when I go to the max function, if it shows me source voltage, did it turn off?
No.
Yeah. Okay? So that's how I know it turned on and it turned off. How long? I don't know, but it turned on, it turned off. Okay? You can use your voltmeter for it. What else can you use on your voltmeter that's going to be able to determine if that is turning on or turning off? If you have an automotive voltmeter, you should have a button that says duty. Frequency. Okay? If I put my voltmeter on that ground circuit and I've hit duty and it says 50%, what is that telling me?
50%.
That means it's on 50% of the time, off 50% of the time. Okay? This is why we need to know every function that our tools do, right? Because it's all what do you have available for that diag. Does that make sense? If you don't have a scope, you can't be like, well, I don't have a scope, I'm not testing it. No, pull out what do you have? Have a voltmeter, pull that shit out, let's work with it. Does that make sense? Okay? Does anybody have a set of Noid lights?
Yeah.
Okay? Throw them away.
Right, that's old school.
Why is a Noid light not a good idea?
Because you can still turn that on with low voltage.
No. An LED requires as little as 2 volts to light. So what if I put it on an injector harness?
But that wasn't an LED, the other one. I think it was like, I could see that.
No, they're 2 volts. I've seen them light as low as 1.5.
1.5.
So you don't use Noid lights. If you have them, toss them, okay, or don't use them, because they could trick you. Okay, I knew a lot of technicians who shove a Noid light in there and be like, oh, oops, fucking, we got power and ground, move on to something else. Is that enough power? I don't know, the light lit, it's good. Okay? Doesn't mean anything.
You know, Christ is very common to go buy the driver for the injectors, you know, pretty much. One you get, and I did it for that.
Yeah, I don't recommend it for that same reason, okay? Because they'll light with about 1.5 volts. So if you, let's say you got a voltage drop on the circuit, so you're only getting 10 volts to the connector, if I plug it in, it's still going to light.
Right.
But 10 volts isn't going to drive an injector.
No.
10 volts isn't going to drive a solenoid.
No.
Okay? So, wanted to share that with you guys, alright? Okay, so here we're looking at the ABS pump in different modes. The first one is the pump's off. How do we know that? This solenoid's off, that solenoid's off, and our check valve is closed. Okay? The one in the middle, the pump is still off, right? But what solenoid's on? Isolation solenoid. What are we doing? Normal braking, we're maintaining pressure. Okay? So this means you stepped on the brake and the pump's holding that amount of pressure for you. Okay? So it's holding the pedal, in theory, it's holding the pedal in that same spot. Even though you keep moving your foot, it's still holding the same amount of pressure to all 4 wheels. Okay? And on the last one, we got the pump running, so we got both solenoids on. We're pressurizing the system. We got a dump valve that's open, and we also have an isolation valve that's open. With the dump valve open, all pressure is going back where? To the accumulator, right? We're holding it there, and then we also have a check valve. When it overpressurizes, we're going to move it back to the reservoir. All right? Are all systems the same? Roughly. Is it always a good idea to verify with the manufacturers that's how they run it? Yes. Okay? This past week or so, when we went to training, we learned something that's very important. Okay? Share it with you guys. The 85-15 rule. You guys ever heard of that?
No.
Okay? What that means is that 85% of manufacturers do everything, or everything's the same. What do we mean by that? Give you a quick scenario. Throttle position sensor. Closed throttle, engine at idle. How many volts should you see? Half a volt. Okay? Is that normal? Yeah. What's the normal operating range of a TPS? 0 to 5 volts. Is that true? Okay? So that's the 85%. The 15% is how does this manufacturer do it? Are they controlling ground? Are they controlling power? What are they doing? Does that make sense? Okay? So that's very important to us. We need to know generically how does this work. Now, is it all the same? No. You got to look up that specific manufacturer and see if it fits. Okay? That's why yesterday I told you guys what's the best answer? Whatever the manufacturer says. Okay? Because it might change. I've had that kick me in the ass a couple of times. Because I'm like, no, that shit works like this. And then when I see how they test it, I'm like, fuck, that doesn't make sense.
I have to say that what you just mentioned is very important for me because that's a point to start, when you're diagnosing about what you were telling me the other day when you got a monitor that is not being run.
Mm-hmm.
And I have seen sometimes 0.8 millivolts in a TPS.
Mm-hmm. That's very important.
Now you're telling me that this is standardized.
Yeah. Yeah. My diet class, I had my students like, yeah, here, check this out. You guys know what a thermistor is, right? What's a thermistor? It's a sensor that reads temperature, right? ECT, engine coolant temp. Is that a thermistor?
Yeah.
IAT, is that a thermistor?
Yeah.
Ford, cylinder head temperature, is that a thermistor?
Yeah.
Fuel tank pressure sensor, a fuel tank temperature.
Yeah.
Yeah. Transmission temp.
They all basically got
Okay? They're all the same. But I have some people that come to me like, dude, I don't know that sensor's, I don't know, I don't work on trannies. Bro, it's a fucking thermistor. Does it work any different than engine coolant temp? No. You test it the same? Yes.
I know inside the
Okay.
like in the computer there is a voltage regulator to keep up to 0.5 volts to keep, in order the battery voltage goes low, still the computer can run the system.
Mm-hmm.
That's the reason for the voltage regulator in the computer.
So the voltage, yeah, go ahead.
But the thing is, how was being applied the software? That now you're telling me this is standardized pretty much.
Hmm? Yeah, so they're gonna, most PCMs use a voltage regulator. They take in 12 volts, drop it down to 5. And we use that for sensors, except for Chrysler, some Chryslers run 8. Okay, so just keep that in mind. You get a Chrysler, it's like, oh shit, I got 8 volts, haha, it's a bad computer. No, that's normal. Okay, so you gotta know what you're dealing with. That's the 8515 that I was referring to, right? So why do we use 5 volts? Well, because that way we know if there's a problem with that system, right? Okay, have any of you guys ever had a car? I know Hector has. I got a car that comes in and you have multiple sensors out at one time. You guys ever had that? Where you get a car that comes in, TPS, you got a code for TPS, MAF, O2s, and all kinds of crazy shit, right? So what are some of the first things you should do when something like that comes up?
Check the 5-volt reference.
VREF, okay? You know how many people forget that part? So here's how hard that test is. I'm going to go find the easiest sensor that's listed as a code and unplug it. Okay? You guys with me? Yeah. If it's a 3-wire sensor, what are the 3 wires of that 3-wire sensor? Ground, signal, VREF, voltage reference. Okay, never say voltage because it's reference voltage. Okay, that's a different voltage than everything else. That's how the computer knows, is this a sensor or is this not a sensor? Okay? You unplug it. Easiest test to do, black lead on the ground of that plug, red lead on the 5-volt reference. Why did I do that instead of going to the ground to the battery? That ground is a sensor ground. That ground supplies all sensors within the car. So if I go to that ground and I go to reference and I get 0 volts, oh shit, I'll leave my power there and I'll move my ground to the battery. If I read 5 volts now, what am I missing? The ground, right? Okay? For those of you guys that have a smog license, you guys should have been taught the 16 pins of the DLC. Pin 4 of the DLC is sensor ground. Is that true? Yeah. So can then I go verify ground integrity at pin 4 of the DLC? Yeah. Okay? If I don't have ground there either, that means I'm missing the entire sensor ground circuits down. So then now I need to go find a junction or something that it all shares. Okay? You see how easily we can get that going? Okay? With this type of system, it's the same thing. Okay? You get a code for it, you got to kind of not guess, but you got to see, all right, how am I going to generalize where this problem is? Okay? You guys ever been taught the difference between a general test and a pinpoint test? You guys ever been taught that? Okay, there's a difference. And there's a big difference, alright? Give you an example. And this is one of the easier ones, this is why I give it to you. A misfire. Car comes in with a misfire, right? How do you guys normally attack it?
Random or specific?
We'll go, you got a PO300 and you got a PO302. So random misfire in cylinder number 2. Check coils. How are you going to check coils? So you're already talking about swapping stuff, right? You're already working. Okay. No. I want you guys to be honest with me. Okay. I'm not gonna bash you or anything. I just want you guys to be honest with me. Car comes in misfiring cylinder number 2 and has a random misfire. Travis said we're gonna swap coils. Okay. What else? What else would you guys do? Swap the plug. That'd be another one. Okay. Like your style, Jose said, scope it. What else? Oh shit! I like your style. I learned a long time ago you don't do that with a pocket screwdriver.
Oh man.
Okay.
To be honest with you, all this year when it worked for me, and it checked. You have a voltage out of the coil, and then from there go to the fuel.
Okay.
And then from there go to the mechanical thing. I just had a Mazda there. Everything was there. When the vehicle was cold, the car started. As soon as it get hot, you wouldn't be able to start it, or the plow would foul.
Okay.
It was the valve, the lifter that was getting.
Okay.
Actually, it was the oil too thick.
Oh, okay. For valve timing. Okay.
No. It wasn't.
Oh, so it was just lifter wasn't hydraulically.
And the lifter, and they were using the special additive. They used what things so that they want to use.
Okay.
We changed the oil.
Okay. And take care of it.
And the car was running.
Okay.
But but the thing is, when it went hot.
I got a good test for you. So now.
When it's cold.
Yeah, but I know there's a way, there's a test you could have ran.
Yeah.
That was going to take you 5 minutes to set up, and you would have known that was a problem. Yeah. So when you get a car that comes from a misfire, okay, most of you guys told me testing, and that testing was already specific, right? Checking the coil, okay? Checking fuel, checking injectors, and swapping coils, swapping plugs, all that fun stuff. That's already hard work, right? Okay? The more you guys know me, the more you're going to find out that as a human, we're fucking lazy, and I'm lazy too, okay? This is how it works, right? So I teach easy, simple testing. Why? Because if it's not easy, you're not going to do it. Right? Is that true? Okay? So, here's what I do. I'll take my scope, and I'll take an amp clamp, and I'll take a lead, and I'm going to put my amp clamp around the ground or positive side of the battery. Then I'm going to take my other lead and connect it to coil number 1. Then I'm going to pull the fuse for the fuel pump. Then I'm going to go crank the car for about 10 seconds. That's all I'm doing. Then I'm going to go back and look at my waveform. If I have a cylinder that's low in compression, I'm going to see it on my waveform. So then I know it's a mechanical problem. Now I can go in there and do vacuum. I can go in there and do compression. I can go in there and do a cylinder leak down test. Okay? Now, what everybody tells me is, I don't have an amp clamp. Fucking awesome, because you don't need one. What you're going to do is you're going to take another lead and connect it across what's called the battery. The reason I love that test is because you're testing the battery, the alternator, the starter, and you're also checking for compression with one test. Okay, that's called a relative compression test. If I want to step it up a notch, there's a sensor called a vacuum transducer. All I got to do is pull the vacuum line for the purge solenoid, shove a vacuum line in there to my sensor, and I'm running the 3 lines, crank it, and if I have a weak pull of vacuum, I know I got a valve train issue. Isn't that much easier than swapping coils? Yeah. Shocking the shit out of yourself with a screwdriver inside of a coil, right? Okay? Or pulling half an intake off to run compression on 3 cylinders to see if those are the problem. Or taking an intake off to swap injectors and a fuel rail, and then you put it back together and you miss an O-ring and it's leaking fuel everywhere.
Those misfires, run on those direct injection systems. You know how...
Doesn't matter.
Yeah, I know, but you know how the valve, how they get so... Good.
I can see that with my vacuum.
But then you're supposed if you can do the how
walnut blasting,
breathing, and all those things is breathing.
Mm-hmm.
I I know, those tools are great, I see people use them.
Yeah.
They're really good.
You don't need those tools. How many of you guys have a vacuum gauge?
Yeah, simple vacuum.
Cool. Pull your vacuum gauge out. GDI has carbon buildup. Shove it in there. Start the car. With the car running, what you're going to see is bouncing needle. Cool. Now you need to do is pull the intake off, walnut blast it, or get some sort of chemical down there and clean those valves. So you don't need a scope. Why do I use a scope? I love fucking pictures. Okay? I don't know about you guys. I love pictures. If I could see voltage represented in a picture, I'll tell you exactly what's wrong with it. Because once you understand how voltage works, you'll see it on a scope. If you're afraid of a scope, grab a fucking vacuum gauge. It's the same thing. The only thing is I'm showing it digitally. Does that make sense? Okay? Vacuum gauge to me is one of the best fucking tools you could have. And most techs don't use them anymore. Back in my carburetor days, that's how I adjusted carburetors with the vacuum gauge. Optimal engine vacuum. Wasn't going to pass smog, but that thing was going to run like a champ. Okay? Customers were happy when I was doing that. Alright, cool. Good. Get it out of here. Comes back, hey man, I felt smog. I knew you were. Time for smog? Alright, take care of something else. Okay? So, do you always need a scope? No. But you can definitely do it with the vacuum gauge. The reason I brought that up is because you need to know, how can I run a general test on this whole system? How can I generalize this whole system? I'll give you guys another example. Car comes in, crank, no start. What's the first thing you guys are going to do? Propane, right? Okay? If you guys were thinking starting fluid, that's okay. Just don't say that out loud because you'll get in trouble. Right? You use propane, right? It's a compressed hydrogen atom. You inject that, the car starts right up. Where are you going? Fuel. What was the general test here? Adding propane. Is it in the fuel area? Yes, it is. So now I need to determine, is it pump, injectors, or control to the pump?
What is a Honda? It's one that everybody knows driving the car, even have 40,000 miles.
Mm-hmm.
All the injections are one was, that's a very coincidence.
They all go out?
Have you seen that? How they doing on big recall on the 2000? We had a couple already.
What year?
Like 2000. Like 3 years old, pretty much like that. Those are.
Oh, so you're talking GDI?
Yeah, GDI.
Oh.
Because they had just started.
Mm-hmm.
They did wrong calculations out, and now they're selling some upgrade ones.
Yeah, they were having issues.
They were having issues. They were melting coils. I don't know if you guys heard about that.
No, but the customer was going to RFC, and then they couldn't start it. And then you just do the propane and then start it. And then we found out was and there was fuel pressure.
Mm-hmm.
Everything, but it was injected, all of them.
Yeah. So they a lot of times too. How many of you guys have a borescope that can oscillate? So you put it in the cylinder hole, and then you can move it up to look up to the valves. Okay, that's another tool you guys need to add to your toolbox. That's cool because the reason being is with GDI, the injector tip's sitting inside the combustion chamber. Can it get and will it get carbon buildup? Yeah. So they get conked up with carbon, you're not going to get any fuel spray. Or you're going to get uneven fuel spray, and that's going to cause a problem. Okay? One of the ways you could determine if it's the injector plug, secondary ignition waveform analysis. You guys ever done that? Okay, all I have to do is put my scope. I have a wand that I just laid on top of the coil, and I'm going to know if there was fuel in that cylinder or not. Or, how many of you guys are at a smog shop? Okay? You guys have a machine called a 5-gas analyzer. It costs you about $500 a month. You have a probe in it. You go to manual mode, you shove the probe in it. You go to crank it. If the car's cranking, what should I expect to see change on the smog machine? Hydrocarbons. If I'm cranking it and hydrocarbons is reading 0, what kind of problem do you have? You got a fuel problem. Okay? Does anybody do that? No. People just think of smog machines for smog. Okay? That machine, if you guys use it properly, make you thousands upon dollars in diagnostics. If you guys know how to use a smog machine. Okay? Those machines are fucking bitching when you know how to use them. Okay? Alright, so let's get back to brakes. I just wanted to tell you guys about general testing versus pinpoint testing.
Leave $100 on you.
Yeah. Tips are welcome. I always welcome tips. Okay, so when we're talking about ABS system, the PCM or BCM is going to be looking at wheel speed sensors. The way we use a wheel speed sensor is it's going to give us a signal. There's two types of sensors that we'll be using on cars. What are the two types?
Yeah, the one that can load, reloader.
So usually we have a 2-wire sensor known as a permanent magnet and a 3-wire sensor known as a Hall effect. Okay? We're going to talk about those in a bit. So those two sensors give information to the body control module. Body control module sees that information and makes calculations and sends output commands to whatever it is commanding. When we're talking about ABS systems, you might get a question that says, how many channels is this particular ABS? When they're referring to channels, they're referring to how many sensors are on this vehicle. If I have a car that has ABS only in the rear axle with one sensor, how many channels is it? That's a 1-channel or single-channel ABS system. Okay? The other one over here is 2 channels. We got 2 wheels that are being monitored. Right? The one over here on the left, we have a 3-channel. That was very common in the early 2000s. We had 1 rear vehicle speed sensor in the differential and then 2 up front. Okay? And then we went to a 4-channel. We're watching every single wheel. If it was up to California, we'd have 5 channels. They'd want to watch the spare tire. Okay? So that's a good thing we don't have California coming up with engineering rules. Okay? So a wheel speed sensor creates an electrical signal based off of rotational speed of each wheel. We use the principle of electromagnetism. The 2-wire sensor has a magnet inside. That's why we call it a permanent magnet. Okay? That magnetic field gets interrupted every time the sensor goes over one of the tooths on the actual reluctor wheel. Okay? So I want everybody to look up for this because this is going to be on the test. You guys see this? They give you a picture that looks very similar to that. Okay? When you're looking at a vehicle at a wheel speed sensor, that could be cam sensor, crank sensor, wheel speed sensor, turbine output shaft sensor for a transmission, input shaft sensor for a transmission. It doesn't matter. Is it the same thing? Yeah. Okay? When you're looking at these types of sensors, okay, there's 2 terms I want you guys to remember. Amplitude, okay, and frequency. The amplitude is going to be the measurement of voltage. How high or how low does this voltage go? Okay? Frequency is how many times does this signal repeat itself within 1 second. When you're looking at a scope screen, horizontal is time. Okay? Vertical is voltage. I don't care what kind of scope you have. You can have a snap-on, you can have Pico, E-scope, whatever you have, it doesn't matter. They all work with the same principle. Horizontal is what? Time. Vertical? Voltage. Okay? They give you a picture that looks like this. Is that sensor going faster or slower than the other 2? So C, everybody agrees it goes faster. Why do you guys say it goes faster? Amplitude got bigger and it has more frequency. Is that true?
Yeah.
Okay?
It's telling it's the same right there.
So this is the same sensor, just different speeds, right? Is it slower here than it is here? Okay? Is B faster than A?
Yeah.
And is A slower than B?
Yeah.
Awesome. So what happens if I have a car that I'm test driving and I notice that one wheel speed sensor looks like A and the rest of them look like C? You guys ever heard of air gap? So that could be an air gap issue, means that the sensor is too far from the reluctor wheel, or a lot of times you get metal shavings that get caught on the sensor, or the sensor just goes bad. Okay? Usually what I do is with permanent magnet style sensors is I learned this from my buddy that's an aviation mechanic. I freeze them. Okay? In aviation, you know how they test parts? They freeze them to below about 30 degrees below freezing. And then they work them. They test them out. The reason they do that is to see if that component is going to fail under extreme situations. When the airplane's at 30,000 feet elevation, it's fucking freezing up there. So they need to make sure parts are going to fail, right? So I had a Chrysler once that I was struggling with a hard start every so often, and I hit him up. You got to use every resource you got, right? I knew he wasn't going to know shit about it, but maybe I could find something. And I found that. Because he's like, yeah, you know, some of the parts, especially like on the rudder, on the tail fin, we actually freeze them and then test them. Like your style, right? So I got to the shop, got my 10 swivel, pulled it out of the bell housing, and I threw it in the freezer. Got back to the shop in the morning and I set everything up. I back probed the connector, had my scope ready. I was like, 'cause I don't want this thing to cool down. I mean, get warm, right? Pull it out, screw it in, connect it, go to start it, dead. No signal, right? I was like, fuck yeah. Waited a little bit, gave it like 10 minutes, warmed up, car started up. Called and ordered a new sensor, okay? So now I tell you guys about that because it worked for me, so you guys can try it as well. When it comes to the 2-wire sensor like this, that's usually what I do. If I think it's bad, I'll take it off and freeze it. Why? Because I'm stressing the shit out of it. Does that make sense? And then I'll retest it, okay? So it works. Try it, right? A 2-wire cam, crank, wheel speed, you can do any of that. Permanent magnet. Don't put it in a bag with water and then try to freeze it. Just put it in the freezer by itself, okay, and then freeze it, okay? So here's a permanent magnet type sensor. It has 2 wires on it. Yes, sir. What's up? Did I miss something?
No, what was it called?
That's a permanent magnet.
No.
Wheel speed.
Wheel speed sensor? Or the signal?
The signal.
So this is amplitude, and then that's frequency. Voltage, time.
So we're using about when they're like more, there's more length.
When it's what, I'm sorry? Oh, when I freeze it? So,
Going faster.
Yeah, it's going faster, but what did you call it?
Frequency.
frequency. So it's more frequent. You're seeing the signal more frequent. What?
That's going to be on the test right?
Yes, they're going to give you a waveform similar to this. See, I even put it right here.
I usually have one now.
They're going to ask you about the signal. So I believe the question says something about you're test driving a car, and you see this scope signal. What does it indicate? It means the sensor's working fine. Okay, so when we're looking at this type of sensor, it has 2 wires on it. If you don't have a scope, you're not out of the water. You can still test this. You pull out your voltmeter and you set your voltmeter to volts AC, alternating current. Then I take both leads and I go here, across the sensor. Then I'll freewheel, I'll spin the wheel. If I get an AC voltage reading on my meter, what is that telling me? Sensor works. I don't know how good it is, but it's working. Okay? So that might not be the problem. You can also remove it, and if you get a magnet or a piece of metal, you could do that in front of the sensor with your meter across it, and you're going to see the signal change. Okay? Do you need to go through all that? No. So here, they're using a scope. We could see the sine wave, the oscillations going above and below 0, so that's telling me that's an AC signal. Is that true? Okay? The next one is a Hall effect. It has 3 wires. What are the 3 wires to the 3-wire sensor? Power, ground, and signal return. Reference voltage, right? Is that any different than the TPS that's 3 wires? No. What about a map sensor with 3 wires? Huh. Remember I told you guys the 85%? Okay? That's it. So it's a 3-wire sensor. 3 wires are reference, ground, and signal return. So what I'm going to do is I'm going to plug my scope into the signal returning to ground. Then I'm going to spin the wheel or go drive the car.
Because the waveform is different, no?
The waveform we're going to see here, because this has a reference voltage, is a square wave, also known as a digital signal. Okay? So that one only rides above 0. 0 to 5 volts. Okay? Again, you are on a scope. Vertical is voltage. Across is time. When you're looking at these, they don't change in amplitude. So voltage isn't going to increase. It's going to stay the same. What's going to change is the frequency. Okay? Have you guys ever diagnosed a Chevy mass airflow sensor? They use a frequency signal. Okay? When you go test for a Chevy mass airflow that comes in for a 101 code, you got to use a scope because it's frequency. They're going to tell you the frequency or the amount of times that the crystal, the piezoelectric crystal in the mass airflow is vibrating based off of air coming in. Okay? So that's when you have to be able to test frequency. Alright? Here we have another screen capture. Which one's faster, the one on the bottom or the one on the top? So this wheel spinning faster, is that true?
Yeah.
Okay? This one's going slower. My cam and crank correlation scope patterns, do they look like this? Yeah. You guys ever diagnose the cam crank correlation code? This is how you're supposed to diagnose it. You see it on the scope, and you're going to see if they're spot on or off. True? Okay.
The voltage remains the same.
Voltage remains the same. So based off of this one, voltage is source voltage, so this might be an Asian vehicle. Okay? Our Nissan uses source voltage instead of 5 volts. So our lab car, we know for a fact, uses source voltage for this type of sensor. Okay? Alright, the stoplight switch. What do we use the stoplight switch for? And it's not for rear tail lights. It's an input to the body control module, right? Hybrids. What happens if that switch is bad?
You won't be able to start.
Car won't start. Okay, car's gonna come in with a dead battery, a dead high voltage battery. And then you go to test it, ICE is never gonna turn on. Why? On a Prius, you gotta hold the brake pedal, right? I don't know about you guys, but if you have a car now, you have to hold the brake pedal to start it. Right? So if that switch is bad, what does the computer think?
You're not present.
It's like, fool, put your foot on the brake. You want me to start this shit? Step on the brake, man. Right?
But
Okay.
sometimes ask you,
Sometimes it will. Okay? I mentioned that because that's a number one missed PID. How many of you guys connect the scan tool and go right? No, yep. Brake pedal switch, good. All right, move on. Right? How many of you guys check that first? Okay? So I'm telling you about it because if you get a hybrid that's not charging a high voltage battery, the ICE isn't turning on, what's one of the things you're going to go check? Brake switch. Okay? So now most of our lights are controlled through the body control module. You guys aware of that? Okay? How many of you guys have upgraded your headlights on your car? Like HIDs or LEDs? Okay? You guys know if you do that to a Chrysler, your Chrysler starts driving down the road blinking? You guys ever done that before? Okay? Because BCM controls the headlights on a Chrysler. Our Malibu, okay? And the same student that had that Malibu had another Malibu that he brought in, okay? He serviced dealers, so we got to chat some pretty cool shit. So he brings in a Malibu, okay? Main concern was lack of power and misfire. Can any of you guys take a wild guess what the problem was?
I know.
Manifold? No, it wasn't even mechanical.
No.
Lack of power.
Oh, you remember the purple lights? Ah.
Gave it up.
Dakota was here when we were testing it. It ended up being a bad head bulb. Light bulb. Okay? They were running cheap LED lights, and the fan was already going out, so the light itself was actually interrupting the signal back to the body control module. So everything was like, it was turning on. All we did was unplug it, and the car just magically just went smooth. We're like, what the fuck? Put on a scope real quick, and we could see all the feedback going back into the ground circuit. It was ridiculous. I think our feedback was like 2.5 volts. Gangster, right?
What you were mentioning about, but the way how they use is different. Like, you know, when ground and short ground of reference voltage that is used by 3 or 4 different sensors. You know? And then shut down a lot of things.
Oh, yeah.
And then you got all those codes. But it was a single sensor. So
Yeah.
which one?
So usually what I do, like if I get a car that comes in with multiple codes of sensors, I go unplug them.
Yeah, but in this case it was a misfire.
On that one?
Yeah, that you're saying.
Yeah.
So, and lack of power.
Well, on that one, what we ended up doing, first thing we did was pull codes. And then once we pulled codes, we saw that we had a lot of voltage codes. So we said, forget the misfire, we got a voltage situation. That's more important. Okay? And most people would be like, it's a voltage issue, let's find this misfire. Okay, well, if I don't have a good charging system or good voltage, is that going to affect everything else?
Yeah.
Yeah. Okay. You guys ever heard of load shedding? Okay. What your car does is your car is like, oh shit, I'm running out of power. You don't need AC, you don't need a fucking radio, you don't need this, but you do need an engine, you do need braking, and you do need turn signals and headlights. So it starts turning stuff off. Have you guys ever lost an alternator and then like, oh shit, my radio turned off.
Yeah.
Oh shit, there goes my AC. Oh fuck, my car died. Right? Yeah, you guys ran into that? Right? That's load shedding. PCM starts turning shit off.
That's new,
Right? Computers are smart, right? So we saw those voltage codes, we started chasing that, and we started noticing the headlights were a little flickering and they were making noise. The thing that gave it away was when we connected across the battery, our scope lead was just all over the place. We had so much noise on the screen that's what led us to start checking for something that shouldn't be there. And the first thing we went to was the headlights. We unplugged them and the noise went away. We're like, ha! There it is. Headlights. Congratulations. You bought yourself some new headlights. Okay? Pretty crazy. Some stuff you come across. And I think you guys figured it out like in, what, 30 minutes?
Yeah.
Something like that? Alright, so, what are we looking at here? Inputs and outputs. Is there a reason why we need to look at inputs?
Yes.
Okay? You guys ever heard the term garbage in equals garbage out? Okay? If you haven't, let me explain it to you. If I have a bad sensor input, I don't care how many computers you change, how many solenoids you change, is it ever going to work properly?
No.
Why not?
If you don't condition.
I got a bad input. Okay? I love to share this story. I'll share it with you guys. One of the shops I was at had a transmission shop, brought me a Mazda MPV. Okay? They had just rebuilt the tranny on it. But it didn't fix the problem. Okay? So customers' complaint was on acceleration, the car would shudder a bit and then kind of sort of fall on its face and then take off. Right? They condemned the tranny. So when I got it, I was like, alright, cool, let's go take this shit for a test drive. So I got on the test drive, sure enough, it started shuddering and then it would boom and then take off. Right? What would you guys do?
You know, the transmission has to do with the engine too, you know, if the engine doesn't have a good power, it will give you, like I have seen when sometimes you have a misfire, coils are going bad, it's big with misfire.
Okay,
It will be
so
data,
think coils and stuff, data?
looking at data.
Data, okay.
For the engine performance.
What else? What would you guys else look at?
Throttle position.
Not fair, Jose. You heard that one. Jose hangs out with me too much. He already knows the story. So what I ended up doing, I put the scan tool on it. Okay. Back in the day, I had a Modus, right? So I was a Snap-on guy back in the day. I no longer am. So I was using my Snap-on tool, put in graphing, and I went for a drive. And the moment the van started shuddering, what I noticed on the throttle position sensors, my voltage dropped to closed throttle. Half a volt. So the computer said, oh shit, he let go of the throttle. Back timing off, close the injector pulse width. Mwah. Is the car going to run? No. Problem for that car was a $12 throttle position sensor. It had a glitch in it. So the moment I got to that one spot, it dropped to half a volt. So the computer saw half a volt as, oh, input changed to he let go of the throttle. Back off timing, get rid of fuel. So, never going to get a code. Because it's a performance issue. The computer can't tell the difference of you letting go of the throttle or it having a glitch. It just sees that voltage drop. Okay? Being it was me, okay, I had to get my money's worth, so it was a short circuit and we had to replace a component. So,
It had a match.
it turned into about a $300 ticket. Okay? I had to teach the transmission shop a thing or two. They sold the tranny, it wasn't me, right? They sold the tranny for a $12 TPS. Okay? That's when inputs are super freaking important. Okay? Does that make sense?
You describe it as perfect, but that's a different meaning for me now, like performance issue.
Yeah.
Like you still got the voltage that the computer needs to see.
Right. The computer's going to look at it.
But it's there, so
As long as within that range, it's okay.
that makes sense.
If the computer sees a straight 5 volts all the time, it's going to give you a code for high circuit.
More my mind.
If your TPS tells 0 volts all the time, it's going to give you a code for low circuit. Yeah, but it's not going to give you TPS performance. They don't have that one.
Real quick on that, because I actually have an issue with one of my wife's cars, and I don't fucking want to deal with it no more, but it's kind of doing the same thing. It's an 01 Jetta. It'll start up fine, idle perfectly fine. You give it any gas, it wants to fall on its fucking face.
Yeah. Check it. Are you drive-by-wire already on that one?
No, but it has a stupid fucking hybrid fucking throttle bar.
Throttle body. So go to the TPS and back pro with your DVOM and watch it. Or put it on your scan tool and graphing. The only one thing you're going to graph is that sensor. Just the TPS. Clear everything else. That's going to give you the fastest baud rate, so that's going to give you the fastest response rate. Check it. Slowly. And engine off.
Yeah.
Never test the throttle position sensor with the engine running. Okay? Because once your foot's all the way to the ground, what are you going to get? Ah! fucking car just redlining, right? And then most of us are like, yep, nope, that looks good. Boom! Oh shit, there goes the piston,
My neighbor
right?
gave me a no.
Yeah, so careful.
Key on the engine off, but you still hit the pedal.
Yeah, key on engine off, so that way it has voltage to it, and then you're going to slowly apply the pedal. If you have a scope, even better, because with the scope, you're going to get the full reading, and then you'll see if you have any glitches or dropouts. Okay? Best way to do it.
And that one's still the 0.5
Yeah.
open.
Since you're not electronic throttle, you're fine. Does it have an idle air control, or is it controlled by the throttle body?
Well, there's 5 wires going to that.
So it's going to have 2 sensors. So then at that point, it's probably going to be controlled by the valve itself, the throttle plate. So you're going to be roughly between 0.9 of a volt to like 1.2 volts at idle.
Yeah, because I know that it has that electric. Like I say, it's stupid because it still has the cable that fucking.
Oh, okay, so it's the hybrid system.
Yeah.
So
But it's not like the Mercedes where you had the cable
APP.
going through a sensor and then it's electric.
Okay.
controlled.
So yeah, I think you'd be around the 1 volt range, somewhere around there, and then you might have 2. So if you have 2 of them, usually one goes low to high and the other one goes high to low, and then they gotta both be within the same range.
They have to like see some.
Right. So as this one begins to increase, this one begins to drop, and they should meet in the middle, and then cross, and then go like this.
There's one.
So that's why you need a scope, because you're gonna scope both of them at the same time. All right. Okie doke. So talking about traction control, what does the traction control do?
Enable drift mode.
Drift mode. It keeps you straight, right? It keeps steerability. Okay, it keeps you stable. How do we keep a car stable?
By not letting the wheels keep, and lock the wheels.
It starts braking, right? Hold the steering wheel straight. It starts braking the wheels intermittently, so this way it keeps the car steady. Okay. How does the computer know? Wheel speed. Okay. So one of the things you guys want to keep in mind when it comes to ABS, stability control, or traction control is this vehicle running stock wheels? Are these wheels the right diameter, and are they properly inflated? Okay. Can all of that affect the speed on one wheel? Oh yeah. Okay. We don't know the threshold, and what I mean by threshold is how low does it need to get before it sets a code. Okay. Some manufacturers share that, some don't. Right? The one manufacturer I know off the top of my head, and this is because I attended a Ford training, was Ford. Ford's threshold is 70%. Okay, that's horrible. So that means in order for the light to come on, the component had to have failed by 70% of its normal rate. That's why on a Ford, you don't get a check engine light for a misfire until the engine took a shit. Okay? That's just how it works. Right? Every manufacturer has their own discretion on how they're going to set that stuff up.
Sometimes just a different, it could be the same size, but it's a different brand. That
can affect it.
That can give it a code.
Mm-hmm. Most of you guys, well, all of you guys are auto repair dealers, right? Shops, California. You guys are all aware that by EPA regulations, you got to inflate all 4 tires when they come in for any service, right?
Yeah.
Okay. And if you're not doing that, you need to have a notice that you're charging for it, or your customer has to sign a statement saying that they either filled it up within the last 7 days or are going to fill them up within the next 7 days. Okay. So if you guys aren't doing that, you need to get up to par quickly. Okay, EPA fines are stupid expensive, and I don't want you guys to get a fine. Right? So with the electronic stability control, what the ABS is going to look at is if there's a wheel that's spinning faster than the other, then it's going to simultaneously apply braking to that, so that way it keeps the vehicle steady. So here we have a good diagram of some of the inputs. Wheel speed sensor, steering angle sensor, brake switch, EPS sensor off, yaw rate sensor, roll rate sensor, master cylinder pressure sensor. These are all inputs. If any one of these inputs is off, that's going to affect the module's ability to make an output command. Is that true?
Yeah.
My throttle position sensor situation. Yeah. That one input was affecting shift points, fuel delivery, and timing. Okay? If I would have never plugged in and graphed data, I would probably still trying to diagnose that stupid thing. Okay? All right, so ECS, electronic stability control. The vehicle is beginning to understeer, oversteer, roll. The body control module detects it in a single value. Sorry, sir. And applies up to 3 wheel brakes until it helps bring the vehicle back within proper stability parameters. When that's happening, your body control module can pulse one valve of the ABS up to 16 times in 1 second. Okay, so that's fast, right? I know earlier we made a comment, is like, can't we stop it in time? That shit turned on and off 16 times in 1 second. Okay, we don't have that speed, right? So that's why we use computers. Okay, one of the things I share with my students is a computer is there to monitor, right? And it does a job way better than we do. Okay, so that's why the PCM's there just looking at all that info. So the features designed into ECS include hill assist, all-wheel drive traction control, engine braking, panic stop, accident avoidance, hill descent control, trailer sway control, and optimized hydraulic braking. How many of you guys have been trained in ADAS? Okay, you guys know that that's the future, right? And by the future, I mean like next year. ADAS. Okay. How many of you guys have a car that shows a little car in your mirror when you're switching lanes, or when there's a car next to you? That's ADAS. Okay. That's been around since 2008-ish, right? And when I say next couple of years is because new cars run out of warranty after 6 years. So then something goes down, they don't want to go back to the dealership. So where do they go? You guys. Okay. So you guys need to get trained on ADAS, because ADAS is the next big thing. If you replace the front windshield on a car with ADAS, you got to recalibrate it, because if the thickness of the windshield changes, your ADAS sensor can now be facing up. So if you're going under an overpass, it thinks it's a car, and you're just going to slam on your brakes. Absolutely. Yeah. I wish we were kind of like Europe. In Europe, you have to be a certified specialty center in order to install windshields on cars that have ADAS. Not just any random guy that has a pickup truck that fits windshields in the back. Yeah, it's a scanner and a tree. So if you're going to do ADAS, your initial investment somewhere around $25,000 to $30,000. To get all the equipment, you need to reset it. Here's a good thing though: the average calibrations run between $1,500 to $2,000.
You like those people with a side view mirror.
Yeah. Yeah. If you guys know any auto bodies that fix cars with ADAS and you're good friends with them, I would strongly get going on that. Why? Every car that gets impacted that has ADAS, insurance is paying you to calibrate it. Yeah. Okay. If you want the shop version of the calibration tree, there's also a mobile version of the calibration tree. Teslas. Okay. How many of you guys work on Teslas? You guys know Tesla? You can. Tesla just opened up their market. You can buy Tesla access to their Mitchell for $3,000 a year. You guys know that?
What?
For Tesla, it's $3,000, $3,300 a year for access to their repair information. If you guys have an Autel that's updated, it has Tesla. You just need to buy the adapter, which is like $200.
You have a different adapter?
Yeah. It's Ethernet. Or you can make it if you want, but better off just buying it. Okay? All right? So ADAS, if you guys don't have that, you need to get on board quick. From the way I know things work, because ADAS is up and coming, it's going to be on the test pretty soon. So once you guys get your license on your next renewal, I'm pretty sure not only are you going to see all this shit, what else are you going to see? ADAS. Okay? All right? So that's why technicians need to keep getting updated.
Wow, but to adjust that, then we would be required to have, you know what I mean, that tool, that's very expensive. That would be difficult.
Well, yeah, I mean, how many of you guys have Autel, or a Scansel, a good Scansel, okay?
We're gonna have to buy.
Does anybody have an Autel that's like the 919 or an Elite?
I got it.
Autel Elite. The Elite does it, the 919 does it, the Ultra does it, the Zeus does it. So a lot of these Scansels already do it.
Yeah, but do you
Yeah.
have a picture in front, you know what I mean?
You got to buy the tree. So the tree holds certain placards, and then you got to set it at certain distances and calibrate it. So the hardest part is setting it up.
And also you have to have a specific room, you know what I mean?
You need 35 feet in front of the vehicle to do it. Question, Dakota? No?
So the tree is $20,000?
Yeah. You can get the basic one for like 12, but then you don't have all the adapters for all cars. So if you get the master kit, it's like 20 G's. Delivered.
Say less.
Yeah. Question? Oh, that's cool. You guys gotta get on board quick, right? All right. So, how do we de-energize a high pressure system if you guys need to service it? Pump it. Why would you want to depressurize a high pressure system?
Prevent any accident when you...
So you don't hurt yourself. Okay. If this system, if the accumulator can hold 1,000 psi, you can only imagine how much more is in the rest of the system. So you depressurize it before you work on it, right? Okay. It's just like a fuel system. Whenever you're gonna do a fuel pump, do you
How you do it?
de-energize it?
Follow manufacturer.
Follow manufacturer specs.
Don't go down
Okay.
the other way.
Don't believe me. Don't believe the book. Who are you gonna believe? The company that sells the car, because they didn't make it, right? A bunch of engineers did. Okay. So first things first. Research the procedure for depressurizing the accumulating the service information. Obviously, right? Then here we're telling you to remove the ABS fuse from the fuse block.
Yes.
Apply the brakes firmly at least 40 times. Verify if there's no power assist. If there is, pump the brakes an additional 10 and then verify and then go from there. And that's it. That's how you depressurize it. Okay? Put it all back together and you're ready to roll. For diagnosis, how do you diagnose an ABS stability control system on a car? Plug in a scanner and follow manufacturer procedures. That's all I can tell you. Okay? Why? Because everything's different. Every situation's different. You got to look at what kind of codes you have, what data you have, and then you're going to make a judgment from there. The car you guys are working on today has a code, so you guys are lucky. Okay? You get free information. So you're going to put a scan tool on it. You guys are going to pull a code. We're going to do some research and see if we can figure out what's wrong with it. Okay? Within about an hour or so before I send you guys home. Okay? All right. So the tools to do an ABS EBC diagnostic is a ABS code, scan tool, oscilloscope, digital multimeter, ABS proportioning valve depressor, or a pressure tester. Most of us are going to use the first three, or the first four. Okay? We got a Snap-on Modus, a DVOM, and then we have a handheld, the hell, kind of, what manufacturer is that? Scope?
Handheld digital filter.
Ew.
That was it.
I don't have one of those.
That's
That's super old.
Yeah.
Damn.
cables and
Yeah, that's
Why does that look like a Nokia? It is.
that's ugly.
Look at box like this.
Oh, the big boxes?
Yeah.
Yeah.
Looks like the controller for Chevy. The other.
Yeah. When I started, the scope that was at the shop that we had was up this tall, this big, and then it had a printer that would go and then you had the sun machine, and then you had to peel off the sides and then give a copy, and then it had a boom arm that you'd move over. So
Trying to beat one. You didn't want to play one.
oh, the bear?
Bear, yeah.
Bear Allen back in the day, huh? Yeah.
Snap-on bar, all of them.
Mhm.
Now he's...
And now Snap-on sucks.
Yeah.
You got Jose laughing in the back. It's not that they suck. They're just very overpriced, and you can get a lot of there's a lot of companies out there now. Okay, so that's what I tell everybody.
Give him more.
Back in my day, you had a couple of choices. Mac, Matco, and Snap-on in Cornwall, if you had a Cornwall dealer, right? So you had 4 choices. Now, it's unlimited, because there's so many scope manufacturers, okay? I have a scope that cost me $199, and it's smaller than my iPhone. It's called the U-Scope, okay?
What do you think about Pico?
I love Pico. I got a 4425 and a 2000 series. I got 2 Picos.
Is that the one you sell here?
We're not distributors as of yet. We are distributors for Autel products and MikeSig. So they're a little bit different. When I teach scopes, they're all the same. Setup's the same, operation's the same. It's just some have different features than others. So just to name them, I got the U-Scope, the 2 Picos, I got 2 Autels, so I got like 8 scopes. So it's just, you kind of start liking certain things about them, and you know which ones work for certain things. I have so many because depending on what I'm doing, I'll grab one. If I'm doing something heavy where the car's going to be standing still, I'll use my laptop base, which is MP408 or the Pico. If I need to go in the car, then I'll grab either my Hontec all-in-one, or I'll grab my U-Scope, or I'll grab my MikeSig, just whatever's available. And so you get used to multiple different types of tools. I haven't used a Snap-on for like 6 years, somewhere around there. Okay, but it's the same thing. All right. Okay, so here's a kicker. Anytime you have a yellow illuminated ABS light, what is that indicating to you?
This is malfunction.
What if you have a red brake light illuminated?
That means emergency something bad.
That means we got brake fluid issue or there's a problem with the brake system, right? Okay? Those are two answers for the state test. Right? And if they're both on, you got a really bad problem. Okay? And that's a question on the test. If both of them are on, what do you do? I have it right there. I didn't include the red one. That was my fault. Red means that you got a hydraulic system. A fault within the hydraulic system. Or the parking brake's on or the parking brake switch. But I believe the question and the answers they give you are for hydraulic. Okay? So you're going to retrieve any diagnostic codes and then look them up. If any warning lamp is not illuminated and the brakes are functioning properly in the vehicle with EBC system, suspect problem that's not monitored by the EBC. You're going to continue with manufacturer diagnostic information or tree, the diagnostic tree, and then go from there. All right, here's a good one, just variable reluctance sensor. So this is a permanent magnet. All they're doing right here is using a graphing multimeter to check it. They spin the tone wheel. I'll turn the lights off so you guys can see it. They spun it. We got a signal there, so we know that the sensor is working, right? Okay, if the pattern is not correct, inspect the tone wheel, check it for damage, any missing teeth or anything like that, and check the air gap. Okay?
Okay, for the air gap, I had seen just to mention, because it makes in the crank, the crankshaft sensor. I mean, they have a little piece of,
the spacer?
Yeah, spacer, but in this case, most of them are already
fixed. Mm-hmm. So the way you're going to do that is kind of compare it to another one. Are they the same length or not?
Oh, I see people putting something else too.
Yes.
So much up.
I've seen people now with like cam sensors, aftermarket sensors shorter than the normal one, so then it gives you a correlation code. So that's one of the reasons why we recommend going OEM. Mm-hmm. But not OEM sensors are not perfect either. We have some stories about OEM sensors. Okay, so here we have another type of sensor. Make sure the ignition switch is off in the run position. Measure the available voltage at the suspected sensor. So this sensor would have 5 volts to it. Make sure you have voltage to it. If the voltage does not meet manufacturer spec, test the circuit for open shorts, high resistance, or ground issues, and repair as necessary. If the voltage to the sensor is within specs, connect your graphing multimeter or DSO to the signal wire. Okay, and then with the key in the run position, spin the tone wheel, and you should get something that looks like that. Okay. So that right there is telling you that there was action, it did pick it up, okay, and that information is going to go to the BCM. If the pattern is not correct, inspect the tone wheel for damage and replace as necessary. Right, and that right there is from one of our students, okay, with that Malibu that I was telling you guys about. Yeah. With a brand new wheel speed sensor. He shot this capture to us the day before he brought the car. Well, the same day he brought the car, right before they left the shop. They sent me that picture. Do you guys see a problem?
Yeah.
Where?
Right there on the
There, and there. Okay? You know how they were able to get GM to replace it and pay labor time? That picture. Okay, when the shop owner called the dealer said there's no way. It's a brand new part. We're not doing shit.
You guys don't know what they're doing.
Yeah, that's what they told him.
That's what they said.
Okay? So then he called me and he's like, what do I do? I'm going to send him the fucking picture. Well, let's see who doesn't know what they're doing. Okay? So service manager got that picture. One of two things. He was like, what the fuck is this? Or he shitted himself. Right? Okay? More than likely, he said, what the fuck is this? Right? But he saw a picture. It looked kind of weird. And they paid him labor time. And they replaced the parts. Right? Okay? But can you guys see how it stands out?
Yep.
Right? This is why I love scopes. Remember I told you it gives you a picture? Do you see anything wrong with that picture?
Yep.
Yeah.
Okay? That's why scopes are the shit. Because you're going to see a picture.
With the digital mode reading, you will show something, but it's not easy to spot it.
You're not going to spot it. And a digital graphing multimeter is too slow.
Yeah, it won't.
Okay? That's why I use a scope. Okay? Your voltmeter can usually do about 200 captures a second. A scope could do up to 2 million captures a second.
Wow.
So which one's more accurate? Does that work as a voltmeter? Yeah. There's times where I've been diagnosing, I don't have a voltmeter. I'll use my scope. Why? Because it measures voltage. Anything your voltmeter could do, this does it too, but it gives you a picture.
And better.
Okay? All right, let's talk about TPMS before I send you guys out. You're going to get questions on TPMS. How many of you guys have ever serviced, worked on TPMS before? Okay, if you have it, you're missing out on money. That is a money maker. Okay? Car comes in, pressure lights on. If you already have like the Autel or the Snap-on TPMS tool, right? Looks something like this, okay? Giant Game Boy. You take this, you power it up, you run it by the wheel. If the sensor is working, it's going to ping a signal to it, give you the number, and give you battery life. If you're doing that to a sensor and you get no signal, what are you selling? Sensor. Okay? If you guys have, your guys is universal too, no?
Yeah.
So, Snap-ons is universal, the Autel is universal. One of the cool things about the Autel is they usually come with sensors. You get like a pack of 8, and your cost on them is like $26 or some shit like that, and you upsell that for like $100 plus your programming and installation, $200 on a one sensor. Okay, and all you gotta do is remove the tire, pop the bead, remove it, put the new one in, program it.
What about the ID number when it's been lost? What you do?
That one's a little bit tougher because you're gonna have to write it. So these tools allow you to write the number on the new on the sensor.
The number, how you get?
It's on the old one, so you got to pull the old one off, and it's going to be etched on it. Mm-hmm.
That's one of the reasons I wasn't really doing it, because all those, and also GM, that you have everything working, you got to go one by one. If you miss a second or something, then the thing doesn't beep twice or whatever. You move it and move it and move it.
That one's hard because you don't have the tool. When you have the tool, it's a fucking breeze.
Can Snap-on do that? Like the scanner won't do it. You have to use it.
You have to use the TPMS tool. Yeah. The Autel scanners, some of them do copy them without the tool, but there is a specific tool for that.
A lot of okay, in case the people take those tires to be repaired and then remove that into a regular one. It's no number anymore. No
Nope.
ID.
So if you get a universal one, you'll be able to control it to the car.
And then the computer will accept it.
Uh-huh.
The number that you will.
Yeah.
So you don't necessarily have to have an ID. I mean.
No. If you have it, great. It makes it easier. If you don't, it's okay.
Any number you just clean it.
You're just gonna create a new one, register it, delete the old one, and you're ready to roll.
Delete the old.
So you got two different types of TPMS. They're gonna ask you about them. First one is direct, and the second one is indirect. Do you guys know the difference? So direct detects low tire pressure via TPMS tool. Indirect, it's measuring your vehicle's speed. Remember I told you guys if your tires are low or you change them, it can affect the speed of rotation?
They look at the,
okay?
at the speed.
One of the questions you get is, what will affect the vehicle's TPMS? And nothing has to do with TPMS sensors. The right answer is going to be wheel speed sensor. If you have a wheel speed sensor that's bad, is that going to affect TPMS? Yeah, rotational speed is going to change, so the body control module is going to assume, oh shit, we got a tire that's low on pressure.
Is that why when you jump in some cars you have it on and it drives to display pressure?
Yeah. Okay? Because you got to drive it.
Because those are indirect.
And when they're direct, they're going to have sensors. Indirect, don't. Okay? You got to know the difference. All right?
So indirect,
wheel speed sensor.
But there is a sensor in?
No. They're using wheel speeds.
It's like the Honda.
No TPMS.
Honda, no?
Just use a regular valve stem, and then it's going to use the wheel speed sensors. If the tires are low, the wheel's going to spin at a different speed. So then that's how I know it's low.
So even if, like you were saying, if they have like a different overall height of the tire, that'll affect it?
That'll affect it, yeah.
So don't tell the customer that.
Yeah, so if you got an indirect one and you don't know about it and you sell them a sensor, you're going to look like a fool, right? Okay? But if you got a car that's indirect and somebody changes the wheels and they don't relearn body control, you're going to get yourself some TPMS codes.
Relearn body.
Okay? Because you got to relearn it, right? Okay?
You change the track.
Yep.
So the
Lifted
direct
trucks.
one,
What's up?
the direct is the one with the
With one sensor per wheel. And usually includes,
wheel speed sensor?
wheel speed sensor would be indirect.
Oh.
Okay, if it has a pressure sensor on each wheel, that's going to be direct. Most manufacturers also test the spare tire.
Yeah, I was gonna say, I
Yeah.
had a customer come in and he said, all my tires are all at the correct pressure and my light's on.
I get that on my car too.
He pulled the spare tire out of the vehicle and it had a sensor in there.
It pisses me off.
Oh, wasn't
I-
what do we want? We didn't be there.
Yeah.
Like that, and it said a 5 sensor. I'm like, 5 sensors? Okay, it's a spare. I open up, there's no fucking spare. I'm like, where's your spare? Well, I took it out to get more room. Put the spare back in and it'll go away.
There's your problem, huh? Yeah. So you gotta know what you're dealing with, right?
So, but on the indirect, you choose, it's obvious that doesn't have a sensor.
Right. So indirect is just looking at vehicle speed. So we're talking about direct, has 1 TPMS per tire, 1 TPMS pressure receiver. Okay, you'll have a TPMS indicator on the dash, okay, and it detects actual tire pressure per tire. Most vehicles have multiple receivers, one in the front, one in the rear. What else is a receiver for tire pressure? It's usually in your hand. No, the key. Okay, your key fob is also a receiver. Okay, so if your key fob is low on battery, will that affect TPMS?
Yes.
Yep. Okay, little trick of the trade, just in case. Key fob.
Oh.
Gotta have a key fob. Yeah, if it's a key fob, that key fob does a lot. Okay, anybody drive like a 7 Series Mercedes? I mean BMW? Fuck, I went way off.
Wow.
Right? That's the new shit right there, huh? So, 7 Series BMWs, the key, when you take it into Beamer, they get a tool that looks something like this. Grab your key, shove it in there. And all they're doing is that key is giving them all the diagnostic information on your vehicle. Okay? All in the key fob. Right? Ford, My Key Technology. You guys know about that one?
Yeah.
Okay? With My Key Technology, if a customer comes in and is complaining about, dude, my car runs like shit. Okay? Well, you got to make sure that he's driving it with the right key. Okay? Because your car adapts to you. It learns how you drive.
That's like the driver 1, driver 2.
Yeah. So let's say, for example, wife and husband switch keys. She drives normal and he drives like, you know what, right? They switch keys. Now he has her key. So the car's like, oh, she's driving, but you're fucking gunning and that shit ain't moving. So you take it to the shop, right? What does the shop do? Can't find anything wrong with it. We can't duplicate the problem, right? Or some shops will be like, oh, you need this, and a whole fucking, right? Okay? And a computer, and a reprogram, right? Then he comes back a couple days later doing the same shit. Okay, that's My Key Technology. You can program the key to do certain things, right? One of my cars, my key is programmed my seat, certain things on the car. My wife's key does certain things to my car. Okay, if I have her key, I know it because the moment I get in it starts killing me. It starts crushing the shit out of me, right? Okay, so that's how I know. I'm like, oh fuck, wrong key. Okay, this has been going on for years. I remember I got a Ford that came in one time. The customer's complaint was, my radio, I can't control my radio unless I go over 35 miles an hour. Okay? That was a trip. I was like, what do you mean you can't control your radio? He's like, it won't work. Right? So I went out there and I'm like, what the fuck? This shit won't work. Right? Had some contacts in Ford, made a few phone calls, and I found out that was a programmable situation. Pulled out the thing called the owner's manual, went to a certain page, and it told me how to turn that off. That's a feature built into the truck.
That's for your report?
That was a 2009 at the time.
Oh, fuck.
Okay? So it's not new. No, that wasn't even the key fob. That was really the key. Okay? So that's where we have to be up to par and know what's happening here, right? Little shit like that can kick our ass. Right? Most people would have sold a body control module, a radio, and then that didn't work. They'd be like, you know what? I got this Pioneer, man. We should have fit right there. It's golden. Yeah, you go watch movies, okay? That's what most shops would have ended up doing. But it wasn't a problem. It was built into the truck.
So what was that feature for?
Gotta love Ford. And said, fuck it, fuck with the radio. Make some more money that way, right? Just change the whole radio and it's still the same problem. So indirect TPMS, indirect systems don't use physical pressure sensors. Instead, they interpret tire pressure based off of manufacturer calculation and speed. Fucking crazy, right? That right there is 100. You guys got an answer right already on the state test. Okay? So, Some manufacturers have a TPMS without an MID. That's an indicator. If you look at the center of your dash and all you have is a light for TPMS, you don't have this, okay? It's just a light. So you don't know how much pressure you have, you don't know if one of them's low, you just have an indicator, okay? That would be a TPMS system without an MID, just a light. Then you have some manufacturers that say, hey, you know what? We're going to tell you what tire it is, which tire is low, and what PSI it has, okay? Honda does that, Lexus does that, a lot of manufacturers do that, okay? No, they have a light. They don't tell you anything. My Scion doesn't either, okay? Some of them will, right? Just depends, okay? Honda was using indirect from 2014 to 2019. I believe they still are. And then they were using direct from 07 to 2014. Okay? Just thought I'd put that up there because they're the ones that have been a little bit different than everybody else. Okay? Any questions? The most important thing I want you guys to take away from TPMS is direct uses one sensor per wheel, indirect uses vehicle speed. Okay? The way I don't remember exactly how the question's worded, but it turns out it's indirect. Okay? They're asking you that there's a vehicle, you're driving it, what's going to cause TPMS to come up, and there's no options for TPMS pressure sensors. Okay? The only one on there would be vehicle speed, wheel speed sensors. Okay?
And it's like an Audi, like 2015 Audi,
Mhm.
it doesn't have the...
You don't have sensor?
TPMS,
Yeah.
so I thought it was a sensor inside the wheel, but it's not.
Nope. It's
It's just the pressure.
Yep. Pressure's low, one of the wheels is spinning a little bit different speed. Yeah. Okey-doke. All right.
You guys would have a question where it would have the ABS, because the ABS and the TPS is on? What was the...
So you're gonna, I believe the question is, vehicle comes in and you have red brake light illuminated and yellow ABS light illuminated, letting you know ABS, you have an ABS system fault, and then you also have a hydraulic system fault. Yeah. Okay? Any other questions? All right, cool. So we're going to go ahead and head on out. We're going to go do a quick lab real quick. You have the car set up already, Jose? All right. So Jose has the car set up for you guys. First thing I want you guys to do